Welcome to The Explainer. Okay, let's talk about AI that can code. We've all seen the hype, this idea that you can just talk to a computer and it'll build whatever you want. But what's the reality? Let's get into it. You've probably seen this quote from Andrej Karpathy. The hottest new programming language is English. It's this huge, powerful idea, right? A future where creating software isn't just for coders anymore. So this dream actually has a name, vibe coding. And the idea is pretty wild. You just describe a feature, a vibe, and an AI agent just goes off and does it. It generates the code, tests it, deploys it, the whole shebang. So what would this world actually look like? Well, it's about breaking down barriers. Imagine a product manager who can build their own prototype, or a scientist who can whip up a tool to analyze their data, all without writing a single line of code. It's a game changer. Look, it's an incredible dream. But let's just hit the brakes for a second. Before we hand over the keys to the kingdom, we have to ask the big question. Can we actually trust these AIs to build real, reliable software in messy, complicated projects? And this is where it gets really, really interesting, because it turns out how we've been testing these AI coders might be a huge part of the problem. Are we even asking them the right questions? So check this out. There's this major disconnect. For the longest time, our big AI coding tests, like the famous FeatBench, have been all about fixing bugs. They test the AI like a car mechanic fixing a known problem. But that's not what human developers spend most of their time doing. Studies show they spend almost 40% of their time building brand new stuff. We've been testing mechanics when we really need to know if they can be architects. So, to fix this mismatch, researchers built a brand new, much tougher test for AI. It's called FeatBench, and you should really think of it as a crash test for AI coders, one designed specifically to see if they can build new features from the ground up. What makes FeatBench so different? Well, first off, it's pure English. No code-ins, just, hey, I want to do this. And it's ruthless. It checks two things. One, does the new thing you built actually work? And two, just as important, did you break anything that was already working? In the dev world, we call that a regression, and it's an absolute nightmare. All right, so the big moment, they took the best AI models, the most advanced frameworks, and threw them at FeatBench. And the results? Well, they were a big reality check. Get this. The absolute best performing AI agent only passed the test about 30% of the time. Just let that sink in. We're talking about a massive drop from those 65% plus success rates we saw in the old bug-fixing tests. This tells you right away that building something new is a whole different ballgame for AI. And it gets even worse when you look at where they're working. On small, simple projects, yeah, the AI does okay. It's successful about 65% of the time. But the moment you throw it into a big, messy, real-world code base, its performance just falls off a cliff, all the way down to 20%. And we see the exact same story with how big the change is. If you ask it for a tiny little tweak, less than 30 lines of code, it's fine. But if you ask it to do anything substantial, anything over 50 lines, the success rate basically flatlines. We're talking less than 5%. It's almost zero. So you have to be asking, what is going on here? Why are these super powerful AIs, the ones that seem to be able to do anything, failing so badly at these real-world tasks? Well, when the researchers dug into all the failures, one reason just stood out from all the others. It wasn't that the AI didn't get the request or that it just gave up halfway through. Nope. In nearly 3/4 of all cases, the problem was something they call regressive implementation. So what is that in plain English? It means the AI successfully built the new feature you asked for, but it broke 10 other things in the process. And that's a deal breaker, right? For this whole vibe coding thing to work, you have to be able to trust that the AI isn't causing chaos behind the scenes. And the reason this keeps happening is because of this really fascinating behavior the researchers spotted. They call it aggressive implementation. And this is a total double-edged sword. Let me show you what I mean. Okay, so here's the bad side of that aggression. In this real-world example, a user just asked the AI to add support for a new C++ version for one specific compiler. Simple enough. The AI does that, but then it gets aggressive. It decides, all on its own, to also add support for a totally different compiler, and it completely messes it up, breaking the entire program. Total failure. But then you see this, and this is where it gets crazy.
that same exact impulse to be aggressive can be absolutely brilliant. In this other example, the AI didn't just slap on a quick fix like it was asked. It took a step back, looked at the code, and decided to completely refactor it, creating a new reusable function. It came up with a better, cleaner, more elegant solution than the human developer's original idea. A huge success.
So, where does all of this leave us with the dream of vibe coding? What's the big takeaway here? Okay, let's wrap this up. The dream of programming in English is powerful, but the reality is way more complicated than we thought. Right now, even the best AIs really struggle with building new features in the real world. And the main reason is this aggressive streak they have, this creative impulse that is both their biggest strength and their biggest weakness. The goal isn't to crush that creativity, it's to figure out how to guide it, how to control it. And that really leaves us with the big question moving forward. We don't just need an AI that's a coder. We need an AI that's a true partner, one that knows when to be that ambitious architect, redesigning the whole system for the better, and when to be a careful, precise craftsman who respects what's already there. Figuring out how to build that, well, that's the next great frontier.